Okay, so we will be taking up discrete joint probability distribution. Suppose x and y are discrete random variables, then the function f of xy is said to be a joint probability mass function if the following properties are satisfied. So the joint probability is always positive or zero, that is for all possible values of x and y. The sum of all possible joint probabilities over all possible values of x and y should be 1. And then the probability that x assumes the value a, y assumes the value a, is obtained by replacing x by a, y by the value of b. And if we consider all possible ordered pairs in region A, then we just take all possible ordered pairs or f of xy within the region in the xy plane. Okay, so from an echo bag containing 4 apples, 3 oranges, 2 bananas, a random sample of 3 pieces of fruit is selected. If x denotes the number of apples and y denotes the number of oranges in the sample, find the following. The discrete joint probability distribution f of xy, the probability that xy, all possible xy such that x plus y is less than or equal to 2, and then tabulate the probability distribution that would show that f of xy is a joint probability mass function. Okay, so inside the bag we have 4 apples, 3 oranges, and 2 bananas. And then we denote x as the number of apples, and then y denotes the number of oranges in the sample of 3. So the number of bananas in the sample of 3 will be represented by 3 minus x minus y. So the number of bananas will depend on how many apples and oranges have been selected. Okay, so the joint probability f of xy will be given as follows. We count the number of possible apples out of those 4, so we'll be using combination, and then the possible combination of taking or selecting oranges, and then the number of possible ways to select bananas based on the random variables x and y over the total sample space, which we have 3 samples taken from a total of 9 fruits, 4 plus 3 plus 2. Okay, so for the number of apples, since x counts the number of apples out of those 4, so that will be the number of possible ways will be 4 combination taken x. For the possible ways of selecting y, number of oranges, okay, number of oranges, that will be 3, that is the total number of oranges in the bag, 3 taken y. And then we have total of 2 bananas, so 2 taken 3 minus x minus y. And then the total possible ways by fundamental principle of counting will be the product of these 3 possibilities. And then you have the sample space, which is 9 combination taken 3. So x will take the value 0, 1, 2, 3. So take note there are 4 apples, but since we only have 3 samples here, so the maximum value of x will be only 3. And then the possible values for y should be, since the total number of oranges is 3, so it can be 0, 1, 2, 3. So this now represents our probability distribution or probability function. Okay, and then we're also asked to find the probability that x plus y is less than or equal to. So what are the possible values, no? Now we cannot choose f of 0, 0, no? Although 0 plus 0 is less than or equal to 2. 0 plus 0 is less than 2. But the probability of 0, 0 is 0, because if x is equal to 0 and then y is equal to 0, the number of oranges should be 3 for the number of bananas, but it cannot be 3 since the maximum bananas is only 2. So it cannot be, so this is not possible, no? F of 0, 0. So 0, 1, if you have x equals 0 and then y equals 1, then the number of banana here is equal to 2. Okay, so this is possible. If we have 0 plus 1 is, of course, will satisfy the inequality. 1 plus 0 is also less than 2. The number of bananas is, if the total sample is 3, so it is possible that B is equal to 2. If we have 1, 1, 1 that is equal to 2, so still within the region or inequality. And if you have x equals 1, the number of bananas should be equal to 1, so 1, 1, 1. So and if we have 0, 1, so based on the previous okay, so this is our probability distribution. So you just substitute, no, the value of x and y. So if we have okay, so if we have 4 taken x, so 0, 1, so 4 taken 0, 3 taken 1, and then the number of bananas is 2, so you have 2 taken 2. For then all over the sample space. For 1, 0, so 1, 0, 4 taken 1, 3 taken 0, the number of bananas will be 2 automatically, so 2 taken 2. If we have 1, 1 here, so 1, 1, 1, so 4 taken 1, 3 taken 1, 2 taken 1. And then computing, okay, this is 1 over 28, this is 1 over 21, this is 2 over 7. And then the probability should be 0.3690, no? All possible ordered pairs that will satisfy the inequality x plus y less than or equal to 2. Okay. Uh, so x cannot be 2, no? Or y cannot be 2. So definitely either the other two will have 1. Okay? And that should be greater, the sum should always be greater than 2. So these are only three possible ordered pairs of f of x, y, or possible combinations of x and y that will satisfy the given inequality. Okay, now to determine if we have a discrete probability mass function, the sum of row totals and column totals should always be equal to 1. Okay, so you have the possible values of x 0, 1, 2, 3, and then possible values of y 0, 1, 2. So for example, this is the probability from the probability that x is equal to 0 and then y is equal to 1. So so using the formula, no, that we obtained a while ago, then x equals 0, y equals 1 should be equal to 0.03571. Okay, so let's say the probability that x equals 2, or f of 2 is 0. Okay, f of 3 2 is 0 because the sum of x and y here is more than 3. And then this is the probability of x equals 3, y equals 0, and so on. And then check the sum of these should be equal to 1. The sum of these should be equal to 1. Okay, so since this is satisfied, therefore we have a joint probability mass function. This is the detailed computation, no? The first column will be the possible values of x, possible values for y, and then 3 minus x minus y refers to the number of bananas in the sample of 3. And then we get the combination. For combination taken x, possible ways to select the apples. Ito naman, possible ways to select the oranges. And then possible ways to select the bananas. This is the sample space. So multiplying these 3 columns, divide by 9 combination taken, it will give you the probability that x is equal to 1, y is equal to 0, and so on. So this is done in Excel. Okay, we go to marginal distribution. So marginal distributions is important in finding conditional probability. Suppose f of xy is a joint discrete mass function of x and y. The marginal distribution of discrete random variable x alone will be g of x equals the sum of all f of xy over all possible values of y. So we fix the value of x is fixed, and then we get the sum of all possible values of y. For in a similar manner, the marginal distributions of discrete random variable y alone will be, so that will be represented by h of y. So this time we take all the possible values of x, and then we fix the value of y. Referring to the tabulated distribution table in example 1, we determine the marginal distributions of g of x and h of y. So from table 1, okay, g of x is the row total, and then h of y will be the column total. So going back to the yan previous example, this is the, so each of this is your g of 0, this is g of 1, g of 2, g of 3, and then the column totals refer to h of y, so this will be your h of 0, okay, h of 1, h of 2, h of 3. Okay, so from, okay, for g of x, okay, we have g of 0, g of 1. So take note that we fix the value of x and then take all the possible values of y. Okay, for g of 0, g of 1, g of 2, g of 3. And then in a similar manner, the h of y will be the column total. Okay, the column total. The value of y will be fixed, and then x will be from, we get all the possible values of x, 0, 1, 2, 3. So that will be your h of 0. That is the first column total, the second column. This is the column under y equals 2. This is the column, the sum of the column under y equals 3. Okay, what is conditional probability? So, if x and y are two discrete random variables, this is 2, correction. The conditional probability of x given y is equal to k is given by, so if x will be within a given interval satisfying all integers between a and b, given y equals x, we take the summation from x equals ab, so f of xk over h of k. Now if this is a single value, okay, this is a single value, so we only get, let's say if x is equal to a, for example, then the conditional probability will be f of a k over the marginal distribution h of k, provided that k should be greater than 0. And then for conditional probability of x given y equals k, so this is for given interval, we take the sum of all possible values of x satisfying this inequality, so f of ky over g of k. So we replace x by k, and then in the denominator we consider the marginal distribution of x at x equals k. Again, g of k must be greater than 0. So going back to example number 1, we find the probability that x is equal to 0, y is equal to 1. So we find that we find the probability of x given y, where y is equal to 1. Okay, so if the variable here is y equals 1, so we consider the marginal distribution at y equals 1. Okay, so what is h of 1? We retain 1, 1, 1, and then we get h of 0, h of 0, 1, h of 1, 1, 2, 1, 3, 1, and then we get the column total, no, at y equals 1. So this is the column total at y equals 1. Your h of 1. And then the probability of x equals 0 given y equals 1 is f of 0 given 1. That is f of 0, 1. This is your x and then your 1 over h of 1. So we have 0.537. This is your h of 1. And then from the table, f of 0, 1 corresponds to 0.03571. Okay, so computing, we get the probability which is equal to 0.0667.